Welcome to a new lesson. In this lesson, we'll look at how the jobs are scheduled in MapReduce framework. The general scenario would be that there would be multiple users issuing the jobs on Hadoop distributed network. The scheduling scheme would be employed at Job Tracker in case of MapReduce 1 and Resource Manager in case of MapReduce 2. One of the following schemes can be set up in MapReduce framework. First in, first out, also known as FIFO scheduler, fair scheduler, and lastly capacity scheduler. MapReduce 1 comes with a choice of all the three with first in first out as the default, and MapReduce 2 comes with just the fair scheduler and capacity scheduler with capacity scheduler as the default. Let us understand what are these schedulers and their pros and cons. Let us start with first in first out scheduling scheme. Very early version of Hadoop employed this scheduling scheme in the simplest form. This diagram shows nodes, slots on nodes, the priority queue, and the jobs inside it, and the job tracker. The slots can be further be divided into map slots and reduced slots, as there are supposed to be fixed number of both the types of slots in classic MapReduce. I have not shown that detail in this diagram as it is not related to the main idea that needs to be shown. So the job that was submitted first would take up all the resources and would be executed first. In this case of scheduling, if a large job was submitted just before a small but a high priority job, the user of the small job would have to wait for an unreasonably long time. This situation was a little improved by deploying a priority scheme along with this. So now the jobs could have been prioritized to very high, high, normal, low, and very low. So the situation improved a little as the smaller high priority jobs moved high up the order, but still in this case the preemption wasn't possible, and so the smaller job had to wait for a long time if a longer process was already taken up and was under process. This scheme gives clients unequal share of the cluster and random turnaround time. Next we look at the capacity scheduler. This is the default scheduler which comes with MapReduce 2 or YARN setup. This takes a little different stance to multi-user scheduling. In this case, queues are divided on the basis of users or groups of users, which is termed as organizations. This scheduler is designed with an idea so that the same cluster can be rented to multiple organizations and the resources may be divided to serve the specific requested SLAs for the organization. Thus, the organization need not make their own cluster, but they can rent out a portion of cluster which would be apt for their services. So in case of capacity scheduler, there are multiple queues specific for the organizations. Each queue is given a portion of resources of the cluster. These generally are soft and elastic allocations, but can be configured to hard or in many different ways on the basis of requirement. Let us see this with a simulation run. Suppose a job enters organization's A queue. So it would be picked up as there is no job running. Moreover, this would take up as many resources as much as available. This would effectively utilize the cluster. When a job in organization B appears, tasks of the first job would be killed to free up the slots for the new job. There are many features available in this scheduler like capacity guarantees, elasticity, security, etc., which can be customized by the administrator for the situation. Next we look at the fair scheduler. Conceptually it is very same to capacity scheduler with minor differences. Like the capacity schedulers, the queues are divided and here they are termed as pools. So the jobs would be picked up from the pool and would be given their portions of the resources. Suppose if another job comes to the pool, the capacity scheduler would process it like first in first out or first in first out with priority. In this case, a small high priority job has to wait for a long time. So this situation is a little improved in fair schedulers, that the jobs which have waited in the queue would be picked up and would be processed in parallel so as to give a better user experience. This scheduler is in beta state and the work on it is still going on as I make this video. This completes our discussion in regards to scheduler. See you in the next lesson.